Hi everyone. Welcome to the MathSpellBook live stream. I'm your host Peter, and we're getting back to relative velocity. In addition, we'll probably look into a little bit of special relativity, because I thought, since we're doing relative velocity based on observer's point of view, from one observer to another, I thought, why not just expand on that and go into special relativity, which basically is based on all observers. So why don't we just get into it, shall we? So I'm going to copy this problem because I actually tried to do the first one, but unfortunately I didn't get it right because perspective played a part in it, and I actually did some of the numbers wrong on that one. So hopefully the second one, this one won't be as we'll be able to use the skills that we learned before. Okay, so I guess we're gonna have to, because this one is actually part of this. So the thing is that I kind of remember how to solve it, but the thing of it is that I feel as if it's kind of cheating. That's the reason why. But I guess we'll do the first one. Okay, so the way this goes is that, so we're doing 3.35 first. So we got a river that flows due south at a speed of, and this is the river in perspective to the Earth, which is equal to 2.0 meters per second. And then we have a man steers a motorboat across the river at a velocity relative to the water, so, and they're going east. The motorboat across relative to the water, so we'll put B here, and then so we can have the vectors, so the vectors will kind of give us a better picture of what's going on. And that's due east, and the river itself, we can just basically, the distance between the river and the others, the rivers from one side to the other is 800 meters. Okay, so question A is basically, what is his velocity and the direction relative to the Earth? So basically, we have to think about the river being one entity and the boat being another. But we also have to remember that the equation we're looking for is that we're looking for the boat relative to the Earth. So, and that would be equal to the boat relative to the river plus the river relative to the Earth. So that's the equation we're left with, and luckily for us, they're going in they're not going in totally an angle direction, they're going 90 degrees of each other, so basically we don't have to worry about things like trig functions. So if we do this, then we're gonna get the magnitude of this. So technically the boat relative to the Earth would, we have to think of it as sort of like a linear equation. So for the x-axis, we are given by this expression, and then plus 2 meters per second J. So that's usually how it's written. Actually, I should erase these, because what we want to get is coming up next. That's what this is. I should write a vector here. So go this way. And then we basically have to put everything into place, like so, to get the actual magnitude. So the magnitude of that, take out my trusted calculator, then 4.2 plus 4.2 squared plus 2.0 squared, that gives us 465 meters per second. So that is the magnitude. Now we have to actually calculate the direction of the vector. Now the vector should be like this, and we have to determine the angle here. So if that's the case, we have both opposite and adjacent, so this calls for a tan function. And now the thing is that now this is where I messed up though, because in the problem I remember doing it this way, but then I also have to think about the angles, like where the different angles are. And the thing of it is that we're trying to calculate this side, so the angle we're looking for is actually over here. So I almost made the same mistake again, but now I remember it, and even I forgot it at some point. So I think like what I'm trying to say is that sometimes when it comes to these type of problems, we have to ask exactly like where the angle is, and I think that's sometimes not obvious, because like obviously you have an angle here and you have a 90-degree angle here. So I'm saying it because like it's a reminder to myself as well, so you know. I think like this is why many people that study physics, or at least physics professors, they say like draw a picture, because when you draw the picture you actually will be able to understand. Because like when I think about the angle here, it kind of does make sense, but at the same time it's like, what is the angle supposed to like help tell about the whole entire system, I think. And I think that's the best way I can quote it. But so this one is treated as the opposite, and this one is treated as the adjacent. And I think then we're left with 64.5 degrees. That's all A. So for B, now we have to determine what was the question? How much time is required to go across the river? Okay, so that's go across the river. Now, I also got this one wrong because I used this velocity right here, but I really should have used the velocity of just the boat. So, so what we remember is that this, so the distance we have is 800, so we should write that down here, 800 meters. Now, what we remember from just like doing the algebra is that time is going to be equal to the distance over the velocity. So in this case, just take out our trusted calculator, and then so we're doing the velocity of the boat. So the boat relative to the river. So and that is equal to, well, actually we should write it where all the information spots are. So the velocity of the boat on the river is 4.2 meters per second. And if we do the 800 meters divided by 2, and then we're left with 190.5 seconds. So if you actually divide that by like 60 minutes, or I should say 60 seconds actually, because it's seconds. So that's literally like 3 minutes. So roughly 3 minutes. Now how much time is required to cross the river? Did we do that question already? Oh, what is the velocity of the boat relative to the Earth? Oh no, that's the other question. How much time is required to cross the river? How far south of his starting point will he reach the opposite bank? Okay, so this one I don't remember that well, so I think we got like the amount of seconds, so I think we have to take the velocity of the river into account. How much time is how far south from his starting point will he reach the opposite bank? So if that is the case, velocity of the river to the Earth times time, because that takes how much time, that's how much time it takes for him to go across, so it's during the time when he's crossing the river. So then 190.5 seconds, 381 meters. And I think those are the answers for the first one. This one's chapter 3, so let me just open this. I think we can go to problem is number 35. All right, so for this one, and yeah, we got close to that. Yeah, it's like 468. And then the angle, so let's see, tangent. Yeah, so they did it this angle. So let's actually, because like I want to see if they wrote a better explanation on how to actually like determine which angle is which. It's like the more that we learn together, right? This diagram shows that the vector addition from the motorboat to the water and the water to the earth also has their specific directions. Note that the vector diagram forms the right triangle. So I'm guessing this angle is matched with this one because it's symmetric. So it's like this angle here. And when you think about it, the starting point is here. So I'm guessing like the angle we need has to focus on the starting point of where it goes. Let's see, the velocity of the man relative to the Earth has a magnitude of 4.7 and the direction is 25 degrees south of east. I mean, south of east. So if it's south of east, then that means like it's this. Because sometimes I get mixed up when they say like southeast and then say south of east. Because like sometimes I forget. It's like if it's east of south, right? Does that mean basically it's from the angle from the east, from the x-axis to like the bottom y-axis? Because like those things actually kind of like made me confused whenever I was doing stuff like this. So I think we did get 190. Yeah, we got 190 here, and we got 381, and they got like 380 in this one, right? Yeah, they got 380. So our thought process was correct there. So I'll just pull this down over here, and I think what we can do is just copy this, paste it down here. Alright, so now we have all the answers for the first one. Now for the second one that we did not do, let us actually do it now. So in which direction should the motorboat in exercise 35 head in order to reach a point on the opposite, like directly east from the starting point? The boat's speed relative to the water is... Okay, so... So the river is still going this way, so we have river to the earth, that's equal to 2 point, I hate it when I write, when I don't have enough space. The river is perspective to the earth. And 2 point meters per second. So what we want to do is get from here to here. The problem is that we're going to get pushed because the rivers flow. So I think what we should do is erase this. Now, what we want to do is get up. What we want to do is have a path here. Right here. Meaning that the boat would have to go against the current this way. So I'm thinking that this would have to go now. We also have to determine the angle at which, so this angle is going to be important because it's at our starting point. So, which direction should the boat travel? So, if we take the angle here, so this would be an adjacent angle. No, yeah, this would be an adjacent leg. So this one's cosine. So cosine of let's see how that is. Divided by 4.2. So that's 61.6 degrees. So that means the boat has to travel by northeast. It would have to go by northeast. The 61.6. If it were to start from here and then like try to get to the other side. But then again, I mean, technically it's the same way if you start from here. You just want to get to this side, like dot 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 dot. And the river's still flowing this way. So you want to get to this side, but you have to go here, so this angle might not be it. It might be this angle. So this one. I mean, technically, because from east to north, so basically, so at this point, yeah, so it's like north of east in this point. So this one. So it's still practically the same. In order to reach this new point on the opposite, the boat, let's see, the boat's... What is the velocity of the boat relative to the Earth? So, at this point, the velocity of the boat relative to the Earth is equal to the boat on the river plus the river to the Earth. So now we actually have to do with trig functions, so because the boat on the river is going to be equal to I plus cosine, and then for the river itself, it's just going to be means that this would be equal to cosine, I think it's the angle, 5. Okay, what is the velocity of the boat relative to the Earth? So, B. That's right. Maybe I have to add this instead, because I made it a negative because the river's pushing down. Because this basically says that the boat is going slower here, but that is basically based on the perspective of the river. Okay, how much time is required to cross the river? I mean, the velocity, maybe it's being slowed down because of the river. That's why it's much less. Because this one, I think it's going with the river. So I'm thinking it's slowing down because of the river's push. So it could be right. So let's just box that for now. And if I'm wrong, I'm wrong. We learned something either way. So I would have to say north of east. I think that's the best way to put it. And we'll box that too. How much time is required to cross the river? So I think it's the same way we did it the last time, so but this time the boat is going against the current. That's the one thing, because it's gonna probably be slowing down a little bit because it's going against the current. So I'm thinking we're gonna have to do this one. So it's gonna be, because it's still 800, so this one is like 800. No, meters per second, 800 meters. And I'm thinking we have to do the boat. Because actually, why did we have to do it from, let's see, southward? That's how south it goes. Now, okay, this requires careful thought. To cross the river, the man must travel 800 meters due east relative to the Earth. The man's velocity relative to the Earth, but from the vector addition diagram, the eastward component of equals So they're equal to each other, the vertical component. So now we have to look at what we have here. So for this one, so I'm guessing we're probably gonna have to do this one, because these components, because according to this problem, or at least the last problem, it said that I'm trying not to look at the solution in the next one, so addition diagram of the east component is equal to this. So in this case, we probably have to divide by 2, I think, because 2 is the x component in this one. So I think it's x, and if we do that, the time should be equal to 800 divided by 2. That'll take 400 seconds, which is equivalent to 6 minutes. Well, roughly 6 minutes. Maybe close to 7 minutes, actually. Hopefully that is right. So let's check it out. So let's see. Well, we got the direction right. It's just that we got the angle wrong. Yeah, because when it comes to this, like, I'm like wondering, where do you get the angle from? What is it that I'm missing right here? For B. Oh, they just used the... This one. Yeah, we totally got this wrong. So let's take a look. Maybe I have to... Yeah, this is like one of the moments where it's like the more you learn physics, the dumber you feel. That comes with the territory. Okay, so I gotta look at this differently, because they did the starting point here, and you're supposed to get the angle here in this problem, but this problem they expect you to get the angle here. So, and this is the end point. So, is it basically based on the destination? Because that's the one thing I'm not getting. I mean, you cast off here, and basically the angle is made from this direction, I think, because you're going down here. And I guess this is the resultant. The resultant is, we want it to go this way, but it's not really the resultant. This is. So, let's see, what do they say about this problem? It takes longer to cross the river than the problem, and yeah, that one I figured. In the direction, my thinking was right on that. It's just it's less than, yeah. Now, oh yeah, because this one is like, you have to minus it because it's going against the river. I forgot. So I wrote the wrong equation here. It should be minus. Right here. So this one's wrong. I thought we were getting close, but I thought I managed to understand how these type of problems work, but I guess not. But it happens, guys. It happens. Okay, so I guess now it's just a time to reflect on what we got wrong here. So we got the wrong angle here. So now we gotta understand why is it that that angle is specifically the right angle to take here. Because the first one is this angle, and the starting point's here, but this one is the end point. So I'm like, what is it that we need to do? Like, I mean, like, how do you determine which angle to use? I guess I'm gonna have to go on ChatGPT to understand, because I mean, I try not to, like, I mean, ChatGPT basically helps me understand stuff that, because mostly I notice that whenever I do questions, I always, whenever it comes to like something that seems kind of like, dang, like now I'm losing my train of thought. When it comes to like questions that revolve around a specific like thought process, and I don't understand the thought process, that's when I have to basically go to ChatGPT to basically like get a better idea of like what exactly is it that I need to do. These two questions, I'm getting lost at, let's see, drag this down for you guys so you can see too. Alright, so for the angle choice explanation, we put east as a reference axis. The boat intends the direction. Then measure the boat southward. Measure the boat southward. We put the east as a reference axis. The boat's intended direction. When measured, the southward drift used Sorry, I thought I was gonna. Sorry, guys. Sorry about that, guys. So we put east as a reference point. So let's take a look at this. So the east is the reference this way. Boat's intended direction, then measure the southward drift using the tan, so south component and the east component. That's why it's south of east. Now for the boatman to arrive directly on the east starting point, i.e. no southward drift, let's see. The angle choice explanation. Here the reference is again the east, but now we tip the boat's head northward just enough so that it is northward velocity cancels in the river. That way the net velocity has no south component, only east. I'm starting to form a little bit of an epiphany in my head. So this is the starting point, and this is right here. So I guess you use the angles depending upon like what you want the velocities to measure to. So that's not the good way of phrasing it. I had like the image I have in my head is like, because we have this angle, and since we have this angle, I'm imagining that we're like, since we start here and we want to end up on this side without having to worry about drifting south, we have to kind of like think of it as like this angle is going to go down and squish itself. For this one, I think it's like, since we start here and we go this way, this angle is going to squish itself, but we're going to get pushed by this one. So I think it depends. So the best way I can think about it is that if you want to go straight across without drifting off, you have to think about the angle that's like basically the reference point here. I mean, that's the best way I can think of it. It might not be the best way to fill in the gap, but I'm trying to find the right words so that if you guys encounter the same problem, you guys can use that. Because I'm thinking that the reason why you use this angle is because you know you're going to be drifting this way, and obviously it's not going to push you all the way back to where you started. So this angle, if you wanted to just go down the river like this way, you would have to think about like this angle. And you would have to think about like, okay, what would I need? What angle would I need to make sure that I end up on, like, still on this side, but just drifted a little bit. But of course you wouldn't have to think about the angle that way. I mean, I probably wish there were more problems like this. Maybe I can ask ChatGPT to produce a problem like it. Can you produce example problems similar to maybe if I do more of these, it might help me think about it better. Oh, it gave the answer I don't like. Yes. At least it asked me that, so I don't have to type it over. So let's see this example. So a river flows due west, and a swimmer heads due north with the velocity relative to the water. Okay, find the swimmer's velocity. So it's the ground. The only thing that ChatGPT doesn't add is pictures. So I think for these type of problems, I have to ask where the angle is supposed to be at, or which angle we pick. Okay, so let's try these out. Everything doesn't have to be from the book. We can just basically just... Yeah, I don't like the way this looks. Cut that. I think we can do it like this, like we always do it. Okay, so let's practice these problems, so that way we can get a better idea of what we need to do. So, river flowing due south. Wait. I don't want to do the same problem. I don't know why it gave me the same problem that it did before. I mean, from the textbook. Let's see, the boat's velocity relative to the water. Yeah, that's the same. I don't want to do that one. Okay, here's a different one. Because I don't want to do the problem that's so similar, because it's like, oh, I memorized it. I'm gonna actually like push my thinking, so I can actually like think, like connect it. Okay, so here we go. A stream flows due west, so stream flows due west, so this is a stream relative to the earth at 1.5 meters per second, and a swimmer that swims due north relative to the water, so make it a little bit longer. So we'll just put W for water then, because we have a swimmer. So swimmer relative to the water is 3. Okay, So find the swimmer's velocity relative to the ground. Alright, so at this point, and the magnitude, okay. So we have this. Now before we start drawing angles, I have to think about exactly how we're going to do this. So the equation for the swimmer on Earth is the swimmer relative to the water plus the water to the Earth. And that together is the vector technically it would be like that, and then the magnitude of that plus 3.35 meters per second. And now for the direction. Now we have to think about the direction. So we're going this way, and then the water's going this way, and we have it right here. So right now we're not concerned about from the starting point, so we're not worried about this. So I don't think this angle is going to be it, so I think it's going to be this angle. So the angle here, because I think the best way to think about it is that are we trying to get to the parallel to our starting point, or we're just gonna try to get to the other side? I think that's the only way I can think of it in that way. So if we're just going to the other side without worrying about going in a straight line here, then I think we have to use this angle. So let's see. So this would be if we have tangent. Oops. So in this case, we want the opposite over the adjacent, like that. So that's 26.6 degrees, and that would be west of north, because the angle is being made from here. So west of north. Alright, so oh, that's the first one. We were doing number 2. West of north. Okay, cool. So, and we got the total. Yeah, we got that one. So they actually give the answers here. Okay. All right. Okay, so we managed to solve that one. So let's try the third one, because they gave us 5. So might as well try them all, just so we can get a better feel about what's going on here. Because I think relative velocity is what I struggled with because of this particular type of problem. Because I'm like, why is it that they're able to do the angles like that? Okay, so we have a river that's flowing north. So it's flowing north this way. The velocity of the river due to the earth, and this is equal to 1.8 meters per second. And then we have a boat moves relative to the water at a speed. Oh, now we got an angle. So directed north of east. So the angle is this way, north of east. So here, and this is 30 degrees. And it's traveling with the velocity relative to the water. So this is boat relative to the river. It's equal to what is the actual question? Oh, here it is. Let's just copy that. Can we expand that? There we go. There we go. Okay, find the boat's velocity relative to the Earth, magnitude, and direction. Okay. Alright, so we don't have to go to the... Okay, so we don't have to line up with the opposite side on the same angle. I mean, in the same trajectory as the starting point, so that's something to keep in mind. So the equation that we have is the boat relative to the Earth is equal to the boat to the river plus velocity of the river to the Earth. Okay, now, so now we have like, boat to the river. So now we actually have to do like actual trigonometry here, because we have this angle and then we have this. So the river is actually pushing this way. And I probably should draw this right here. So that way we have that that's the river. So find the boat's velocity. So we have 3.6 cosine of now for this one, so find the relative. So this is 30, so this side will be 60. Now, it's not telling us to basically measure from here. So I think we're gonna have to use the 60 degrees. Now the question is that does that make a difference though? Because I think it's at an angle, so if it's at an angle, we might have to take the angles into account while doing the addition here. I mean, if we were to pick this one, so I would say that the direction might be a little bit easier. So the angle is, wow, I don't know what's up with my pen there. 60 degrees east of north. But then again, it can also be 30 degrees. But then again, we also have to calculate the whole velocity, so that might not be beneficial. Okay, so I think when we combine these, I think we're gonna have to, so. Alright, so we have boat to the river, which is 3.6 cosine. Why is my, could be the app I'm the program I'm using. I'm like, why is it like not writing what I want to write? So 30 degrees plus 3 point sine of 30 degrees J. And then for this one, from the river, this one will just be sine it won't be sine, it would just be this. So now we just add just these two. So the boat to the earth is equal to, so this is cosine 30 degrees, so we get 3.12, and then plus of sine plus 1, so 3j, like that. Okay, now we gotta take the magnitude of that, so so 3.12 to the square plus 3.6 squared. Probably didn't have to write that. 4.6 meters per second. Okay. So now we got the magnitude. Now we just have to figure out the angle itself. And now I have to think about this for a second, because the totally, so now the angle, because the thing that's different about this time is that the vector, the velocity of the boat isn't at an angle. It's not a perfect straight line. Well, it doesn't make a perfect 90-degree angle, so this makes us think a little bit more. in, Rushback 99. What's the best part of your day so far? Because I see you're the first time chatter here. Welcome in, welcome in. Hopefully your Tuesday's going well. So maybe I have to draw this over, because like I think this drawing might not be best for this type of problem actually. Because the way I'm thinking it, it's almost over. That's fair. Like, what are you up to right now? Are you studying? Are you working? Like, what's got you so excited for like the day being complete? I almost said die. Okay, so I'm going to do this over. So the river from the earth is meters. Oh dang! I hate it when I squish it like that. Because I'm trying not to make it too invisible to you guys, so I want to make sure that it's correctly laid out. And I feel like I should draw the angle like this. And we'll just draw it like that. So 30 degrees. North of east, so basically it's this way. Okay, cool. And this one is the velocity of the boat relative to the river. Go over lecture notes of analysis because I don't understand. Diddly squat. Okay. Is that real analysis? Because I'm actually trying to learn that too, actually. But like I've been like going on and off with it. I haven't even gone through the first section of like real analysis. Like I don't remember the theorems that well. I know the triangle inequality and all that stuff, but doing proofs, I feel like I'm not ready for that yet. Yeah, so I feel like this is the right way to think about it right here. Because since we have it at an angle, so this is 30 degrees from the, so there's like an angle here that we don't take into account yet. So, which means the boat is gonna go in, it's gonna go in this type of direction. Oh, we can't. So we gotta remember this is 30. So I'll just put a little theta there. So theta is 30 degrees. I want to make sure it looks nice that way. So this part is 30, but it's like connected to this one, so I think now we can just basically take the tangent of the angle, like of this whole thing. So maybe that might help us. So like we can imagine that there's a triangle here, and then we can take the angle right here. So it will be the x component and the y component. So I think we can do that. So we'll call this phi, and we'll try this and see what we get. So 49.1. working on some proofs like Bernoullian harmonics, geometrical, and arithmetic equations. Oh, nice. I'm guessing you're doing an undergrad in mathematics, or are you doing like a graduate program in mathematics? So I'm guessing you're a student since you're studying. Unless you're just a hobbyist like me and just wanna like do it for fun. I think that might be correct. Because we're not trying to get to the other side of like at the same alignment. Undergraduate in electrical and computer engineering. Oh, okay, that's cool. So are all these required for your electrical and computer engineering degree? Or you just felt like taking them because you just love math? Because I feel like that's pretty like a lot of math. Because I would understand things like differential equations and partial differential equations, but I'm like, wow, that's like but real analysis, I'm like, interesting. Pardon me, guys. I'm just chewing on my cough drop here. Sorry if you hear me like crunching down. Okay, let's see number 2. Yeah, so they did the same thing we did. Oh, I think, did we get a different angle? Oh no, we got the same angle. Okay, I thought we got something different. Okay, we got that right. So my thinking was, my thought process was correct. Okay, that's good. North of east, okay. Yes, analysis is part of it, in my first semester. Oh, okay, I see. Do you mind if I ask where you're from, Rushback? If you don't want to reveal that's fine. Just let me know. Because, like, I know a lot of people, like, there's, like, different... Oh, Switzerland, okay. Yeah, because I know that, like, a lot of people have different curriculums. And I know with, like, say, like, engineering courses, they mostly make you take, like, a lot of math, but sometimes I don't know what type of math they make you take because, like, some of it's pure math and some of it's, like, applied math, so... Because I know with engineers, they have to take at least up to, like, differential equations and sometimes partial differential equations. But when it comes to like pure mathematics, like complex, I mean maybe complex analysis, but I guess real analysis can fit if you can use complex analysis with electrical engineering. Okay, all right, next question. So I think we're doing pretty well with these questions. So now we're getting more practice with relative velocity, which I think is good. And also, if you guys like math or physics, or you just want a study stream to keep you guys productive, if you're watching this on Twitch, please consider dropping a follow. If you're watching this on YouTube Live, please hit the sub and leave a comment down below and hit the like button. I'm just doing like simple physics problems. Mainly, I'm focusing on relative velocity because I was having a little bit of an issue of like trying to figure out how to do it with like angles and trigonometry. So it's like simple, like I guess for you it probably might be simple stuff since you're doing real analysis. So this is like probably like basic high school stuff for you. Okay, a river flows due east, so it's flowing this way. So the river to the earth is 2.5 meters per second. A kayaker can paddle at 5.0 meters per second relative to the water. Thank you for the follow, Rushback. Everyone needs to start somewhere. Yeah, exactly. In which direction should the kayaker head? Oh, what was that? Did we reach a goal or something? Oh, we reached 120. Thank you for being the 120th follower, Rushback. I forgot that alarm was there. Or that alert, I should say. Yeah, it's like cool to, it's like very exciting for me, like how basically like math is like kind of like able to get like a following on the interwebs. Let's see. So we know that the velocity of the kayaker relative to the water, so KR, is 5 meters per second. So in which direction should the kayaker head so they land at a point directly north of their starting point? I.e. no east or west displacement. Give the heading as an angle and specify the compass phase west of north. Or like, I guess that's an example of what they want. Okay, so let's see. In which direction should the kayaker head so that they land at a point directly north of their starting point? So let's say their starting point is here. So they just want to go north this way. The problem is that the current is going this way. Meaning, maybe we should draw this differently. So, first let me just drag this here. Then we'll use the mouse. No. We'll put this up here. And then we can do that. And then let's say the kayaker goes up here. Well, technically, I think it really doesn't matter, but I'll change it if it gets a little bit too cumbersome. Oh, hello, Akset. Hopefully I pronounced that right. Like, it's good to see you in the YouTube chat. But how are you doing? What's the best part of your day so far, my friend? The kayak relative to the river. Okay, so 30 degrees northwest. I mean, maybe you're right. So now, so they paddle, and in which direction should the kayaker head so that they land at the point directly north of their starting point? Give the heading as an angle. Okay, so all right. So we're okay, and the equation we have is the kayaker relative to the Earth and the kayaker to the river plus the river to the Earth. I mean, probably do it this way as well. Give it a better visual here, because we want to basically be at our starting point and revive back at north. So it's not about crossing the river, it's just basically moving upstream. So if you go this way, I mean, if you go this way, you actually want the river to push you over here. So maybe this angle is going to be important. And I think for this one, it's going to be like the vector 2, 5, and 5.0. And then the magnitude will be plus 5.59 meters per second. And for this angle, if we do arc tangent, and this one would be because what we mainly want to do is get back up here. And these two angles would be equivalent to each other. So I think that would be the right approach. So we are left with 26.6 degrees east of north, because it's just asking for the direction, but I felt as if we should do like basically get all the facts. Yeah, because I feel like, because it's getting to the same point, but it's on the other side, but we wanted to come back here. So if we do go this way, like here's how I imagine the angles work, is that I think of it this way, where it's like you have to think about it as if the angle's going to eventually shrink and eventually go this side. So in order for the river to actually, because we're going this way, right? So we want the river to actually push us in this direction, or at least help us in the way. Interesting name. Has been single whole life. What's the best part of your day so far, my friend? Welcome to the Twitch chat. I always ask that to you guys whenever you come in. What's the best part of your day so far? Because I'm pretty sure there's something. If not, then I would probably say to you guys like, oh, you woke up this morning. You know, if you had to drink coffee and you love coffee, there you go, you got coffee. That's one thing. Okay, so I think that's how we can do that. So let's see. I think that's number 4, right? Yeah, that's number 4. So problem 4. Okay, let's see. Oh, you were right. Watching YouTube? Yeah, that's one. Let's see. Oh, they made it much simpler. Oh, okay. I made it more complicated because I was trying to like remember the techniques I was learning. I mean, it was relatively close though, but actually, let me see here. Must head 13 west of north. Oh yeah, because it's going in that direction. No, I am not a college student. I'm just a math/physics hobbyist. I just basically do it for fun. And like I said before, guys, if you like math and physics or you just need a study stream to keep yourselves productive, you know, drop me a follow on Twitch or, you know, hit the sub button, leave a comment down below. Sometimes I overcomplicate things. So let's see what their reasoning is. Let's see, the river east, 2.5, what net east over west is equals to 0. So the kayaker's west to east component must cancel. And the kayaker must provide a west component. Okay. Oh yeah, maybe I got it mixed up because I was thinking of the, I keep thinking that the angle, the vertical component, I was probably thinking of that as the river instead of the boat. Yeah, I stream from Monday, Tuesday, and Wednesday, from 2 to 4 Eastern time. So maybe I got my like vectors mixed up. Like when I was thinking about it, imagining it in my head. So basically, yeah, because I was thinking of this as the, I was probably thinking of this as the boat instead of this. I mean, it's relatively close to 30 degrees, but then again, I basically made it east of north, which is not right. Yeah, sorry guys, there's literally like a fly in my office, and it's like swirling around my eyes. I'm like, yo, where are you going? Let me crush you. If we're heading, the component must be, okay. If we're heading to measure east, of north to east, it's simpler to say that to measure the angle from north towards west-east, but the usual approach to measure the angle from is north or east. So, okay, let the caretakers, right? So it's just to get the, so minus that would be half. Is there, oh, okay. Interpretation, the kayaker is heading 30 degrees west of north, equivocally 60 degrees north of west. This gives the west component 2.5. That cancels the river. So, okay. I had to think, I guess I have to think like more logically with that, because I think the problem with me is when I do with physics problems, I think I have to apply just a solving technique, and then I'm done. But of course, like, that's not usually the case. What was the best part of my day? So far, it's just doing the stream with you guys. So far, that's the best part of my day so far. Yeah, I think for here, I wasn't thinking deep enough. Because usually when it comes to me and problem solving, I have this bad habit where it's like, oh, I see a problem, I just apply the technique that I just learned and then basically like solve the problem that way. But of course, like, you know, not all problems are built to be like, you know, solved robotically, like sometimes what I do. Okay, I think we'll just try this one. So we got, I mean, granted, we did 1, 2, 3, like we did 3 of these problems because the first one was just a repeat of what I was practicing before, and I didn't want to like just memorize it. So it's like 1, 2, 3. So we'll do this one. It's the last one. Hopefully we can. Hopefully we'll be able to get it. I mean, that's part of the struggle of like physics. You basically like, you just basically constantly do problems, and sometimes your intuition is just wrong. And it's kind of hard to face that sometimes. I mean, for me, like, I have to face that every time I get a problem wrong and I realize, oh, wait, I wasn't thinking of this right. Let's see, your current flow is due south. So, river to the earth is... It's going south. A boat speed relative to the water. The boat wants to go directly west. So, this way. Oops, no, not that one. Boat to the river. Is there a B question? Because it says A. Weird. Okay. What do you do? What job do you do? So I am currently not working. So mainly what I do is like, I just basically stream and take care of my dad because my dad's already retired. So yeah. Like I used to work like 2 years ago, but then I left my job to basically just take care of my dad and also like work more on my content creation. So where were we? Oh yeah. In which direction should the boat point, angle, and compass phase so that the south and north components cancel? Okay. So I'm guessing now we do what we did in the last problem. We're supposed to do in the last problem. Yeah, but at the same time, like, I'm not trying to hustle, like, when it comes to, like, content creation. I just like streaming, mainly. I basically stream on schedule, but I don't do things like, you know, make clips or... Like, if I'm doing a stream with my friends, then I feel motivated to make clips, but when it comes to, like, just streams by myself, I don't make clips because I'm like, you know, like, there's nothing very amusing about the clips that I produce. Like, it's just me on my own. Because I have 2 channels. I have my video game channel and my math channel, which is this channel. So now we have to cancel this component, which means so let's imagine a triangle here. I'm not gonna put the angle because the angle is gonna be somewhere. On my video game channel, I play Genshin, Honkai Star Rail, Fortnite. Right now, I'm like on my channel. I've been playing Hogwarts Legacy, but tonight I probably might like. I don't usually on my video game channel. I stream Monday, Wednesday at 8 o'clock, as well as Saturday from 8 p.m. to like 11 p.m. Eastern time. But I've been playing like Hogwarts Legacy on my channel. But like tonight, I think I'm planning to play Honkai Star Rail because there's a new update. I don't usually stream on Tuesdays, but usually the updates for like Honkai and Genshin, they usually come out like during Tuesdays. And it's usually like later at night. So like probably tonight I'm gonna probably stream like around like 10 p.m. Eastern time. Alright, so what they did the last time was just cancel out this component. Yeah, because we have to so no net. So go directly west. Okay, so so now I have to think about which angle it has to be at in order to prevent like a drift. I don't trash talk. I mean, popular game streaming is mostly about trash talk, right? Not really. Oh, hey, actual education. So I'll give you an actual shout out. Actual Education. If you guys are not familiar with Actual Education, they are another math/physics streamer. So if you have any physics questions, math questions, you can tune into their stream and ask your questions directly if you join their Discord. So please check out Actual Education. They're an awesome streamer. In addition to just basically being like an awesome intellectual. Vector Edition. Yeah, we're doing relative velocity because I got this one wrong, so I'm gonna put a big X here. I mean, I managed to get these right, because the reason why I'm doing these problems is because I got these two wrong, and I was like, oh, and I wasn't understanding where you get the angle from based on the question that's asked. So I'm like, I felt like, oh, I'll ask ChatGPT to give me some questions so I can practice. And luckily I got these two right, but this one I got completely wrong, and I was like, oh yeah, I still have a long ways to go with that. Hey Famish, how's it going? So yeah, please check out Actual Education. Unlike me, he'll definitely get these questions right. Coffee ain't coffee. What's the best part of your day so far, guys? Yeah, but like, I don't trash talk in my gaming streams. I usually just play and focus. But then again, I basically try to talk more during my game streams, because when I get too focused, I don't speak when I'm playing games. And I probably should work on that. I always mess this up. I mean, at least you're willing to like be humble about that. It's just trigonometry. Yes, I know it's just trigonometry, but sometimes when I look at physics, I think it's like, oh, it's just a math problem. But then like when I actually apply like just my mathematical knowledge and not thinking about the physical question being asked, I mess up. And I'm like, oh, that's not what they were asking. Nearly done the course, and for psychology and world civilizations would be easier and just gotta read. Oh, okay. So where were we? Oh yeah. So we have to make sure that this cancels out. So the way I'm thinking about it is that we need this angle to no. So now, because the thing it is that we want this angle. Because here's how I imagined it. Either we want the north part to like fold into this way, or like basically based on the drawing I have, like since the bow is going this way, right? I'm thinking we need this to fold in this way. I don't think it's important though, because there's some gaming streamer channels, like some of my friends. They're very pleasant. They basically just engage with chat. They don't really trash talk, and I think trash talk makes it too toxic. That's the reason why I don't trash talk. And plus, like, for me, it just feels like it's bad manners. That's just me though, but some people like that with gaming channels. Me, I don't like it. I'd rather watch someone play a horror game and just scream and just basically curse at the monsters than them cursing at, like, the people they're playing against. Because I think it's just too toxic to do that. Plus it brings out the worst in you whenever you do that, because you're, like, really going into it. Sadly, I don't find streamers 24/7. Most of the time, it doesn't have a single streamer on Math Twitch community. Yeah, that's the unfortunate thing. But that's why I stream to both YouTube and Twitch. Before I didn't do that because I didn't have like good internet, but now I have at least like fiber optic, so I can stream to both platforms. Yeah, like if you really want to be like do math content, like why not, right? Because like for me, I'm not even like an undergrad in math or physics, but I just like math and physics so much that I just do it. But of course I know I'm not good at it, and like some people that do math content, usually the viewers are expecting people that do math content to be either like PhD or at least undergrad, so they can learn stuff from them. So, you know, it's like there's an expectation there, but I just do it anyway because it's like, hey, I get this problem's wrong, so if you see my mistakes, then you learn not to do them. So, you know. Yeah, I dropped 300 on a new antenna to get enough upload and for multi-stream. Yeah. Like, I live with my parents, so, like, it took me a while to convince my dad to change the fiber optic, because he loves watching TV, and he was, like, worried that, oh, if we change the fiber optic, then, like, if the internet goes, then I won't be able to watch TV. which is what some cable providers do, like, sometimes. Why they do that, I don't know. Maybe I have to, like, ask that whenever I'm learning electromagnetism. Because actually the way I think of it is that either, yeah, like the way I said is like either this vector just folds into this one, or this one folds into this one, and then we can get the angle. Because the thing of it is that if it's this way, then it would have to fold 9 degrees. If it's this way, then it has to fold into this angle to cancel out. So I'm thinking it might be this one. So we might have to do this angle, I think. Okay. Alright, so which direction should the boat go pointing it? Yeah, I'm also a learner. Oh, like you're just learning, like, math and physics, right? Has been single whole life. Is it okay if I call you single? or whole life? I don't know, like, because I feel like if I said the whole name, it just feels like it's kind of like a mouthful. I do like the play, the word play in it though. Like, how would you like to be called? Has been single whole life. If you want me to pronounce the whole name, I'll pronounce the whole name. So, okay. Single's enough? Okay, cool. I mean, I don't know if you told me in chat already, but are you a student or you're... Because I think someone else basically said they were electrical engineer, but I don't know if that was you. Electrical and computer engineer. I'm actually going to go back into the chat to make sure. Because I wasn't sure if that was Rushback or you. Oh, that was Rushback. Okay, yeah. You do business? Oh, okay. So what got you interested in math? Do you want to be like the next, what is it? Jim Simming? I think it's Jim Simons. Be like a mathematician going into business and starting a hedge fund. Actually, single, I'm wondering like where you're from. If you don't want to reveal that, you don't have to. Just let me know. Okay. So, for the boat, relative to the Earth, we are given this expression. Boat to the river plus the river to the Earth. Of course. Now, but that's what we did last time, so I don't think we're gonna do that. So we have the angle and the placement of the angle. Well, we don't have the angle, but we have the placement of where the angle should be. I just like math. Left my study halfway. Oh, okay. Like, what type of math are you studying right now? Like, just for fun? Because for me, I kind of alternate. I go from like physics, then math, and then physics, then math. It's a big rigmarole. I sometimes pick up calculus, but sometimes I pick up math proofs. Okay. So sine is here. The last one they did. So we want it to go this way. So if that's the case, let's think of how we can calculate this for cosine of theta. Because I remember the last one, it was like sine of theta, and we tried to make the I think it was to make the this component go away. So in this case, we have to do the opposite here. And I think that's the right approach. So we literally have to do cosine Let's see if that works. Yeah, I kind of figured it's not going to work that way. Because it doesn't give us like 1 or -1. It gives us a number bigger than that. Unless I have to do it the opposite way, where it's like Because I think the last problem, it was basically taking the... Oh, it took the speed of the boat, so maybe we have to take the speed of the boat here. So maybe I'm thinking the wrong way here, so... Because I think what we have to do is... So the boat speed is 6.0, and then we have... So I think this might work. So let's try that. Because I think we should at least get something for this. So that's 57.8 degrees. Now to figure out the actual direction of that, though. So the river is flowing this way, and we need the boat to basically go... We want it to go, like, west. So I'm guessing because it's flowing this way... Because the boat is going west, and the flow is going south. So in order to prevent the river flowing to disturb the straight speed of the boat, we do have to travel at an angle. Like I would have to say. Well, since it's going south, we probably have to go north, so probably northwest. So probably west of north? Oh, no. I'm getting that backwards. I'm thinking it's probably should be... It's probably north of west, I think. So let's see if that is correct. I probably might have gotten mixed up because I know when it's of something, it has to be like towards that direction. And we're heading towards west, so I'm guessing that we have to go north a little bit, and then we have to, and it basically because of the current, we're gonna go down a bit. So I believe that that's the right way of thinking about it. I hope. Okay. At least they put the answer so I didn't have to ask it. Oh, they use sine too. Oh my goodness. Dang, because I thought when they use sine here, they basically got rid of this component. But then like, oh, so they use sine again in this one. Okay. I guess my thinking was off with that one. Maybe I'm drawing the models wrong. Like, because I'm like... Because usually when I think of math problems, or at least like trying to solve things mathematically, I try to think of a symmetry. And I guess that's what screwed me up with that. But I'm like, what? They use sine again with this? Let's see, the angle from west of north. I mean, I got the direction right. I mean, the, like, you know, north of west. But I just didn't get the angle right. But, you know, I do the best I can because I just want to be able to, like, actually, like, understand these things. But I know if I did went to school or something, I would probably, like, forget this stuff because it's like, oh, I'm learning, like, higher and higher levels of stuff even though I'm, like, completely, like, lost at some things. Because, like, I remember when I did, like, Calculus 2 for the summer semester, I barely remember everything I learned from Calc 2. And I felt, like, so disappointed after that because I was like, I really wanted to learn, but at the same time, like, the environment didn't give me the right chance to learn. And plus I was working on top of that. I was working a full-time job during that time, too. Alright, so why'd they use sine though? When the north component in magnitude is equal to... So the angle north of west. So the way we drew it, so maybe we had to draw the angle like up, I mean the vector here. Maybe that would have been better. Why not use N ES letters for the direction, then locate the starting point, then the river flow direction, and then where to go from the starting position, then find out the direction to jump. This might solve your issue. Yeah, I think maybe I have to actually draw the actual compass then, if this is going to be an actual issue. Because I think the problem is that I am not visualizing it well. I think that's the reason why I'm not understanding like the usage of like the trig functions. Because I think I was just trying to assume that symmetry was going to play a part, and it's like, oh, this actually gets rid of the what we were trying to get rid of, the component with the east and west, I think, in here. Or we were trying to go, yeah, from east and west and just go straight. But this one, we were trying to go from like eliminating north and south, but it's still the same trig function, which means that my thinking was off. But, you know, generate. So I think we're still trying to understand more about relative velocity. But at least we managed to get 3 of the problems. Well, actually 2 problems correct. So at least I understand a little bit of the basics of what I'm supposed to be looking for. But I still have a lot of work to do though. And of course, as a hobbyist, like since I'm not going to school for it, like it really kind of hits me because it's like, dang, I love this stuff and I'm not being pressured by school, but why is it that I still get these problems? Like, why am I not understanding these problems the way I should be? You know? But then again, that's just my ego talking in my head. It's like that negative talk, you know? Sometimes I just have to learn how to turn that off. But thank you for joining me today, guys. This was a lot of fun, and I felt like I was very productive here because basically just didn't move on. We just basically just practice. And sometimes I have a habit of just practicing a lot to the point where it's like, oh my gosh, physics has so many problems. I'm like, I practice too much on one section and then I go to another section and then I have to learn a lot of new skills. And I'm like, dang it, then now I forgot what I learned the previous section. I don't know if you guys have encountered that. Maybe you have. But, you know, it's just like hard to keep up sometimes. Because like physics is so vast, and like when you learn it on like, I guess like just regular university physics, you're given so many topics that you're like, oh man, I have to focus on these other topics and how they relate to each other. But thank you for joining me today, guys. We will be back tomorrow. Probably working on more physics problems. Like I said, if you like physics, math, and just need a study stream to basically keep yourself productive in front of the computer, or like in front of your cell phone, you know, if you're watching this on your cell phone, you know, drop me a follow. If you're watching this on Twitch, if you're watching this on YouTube, you know, drop a sub. I always appreciate it. In addition, you know, like hit the like button and leave a comment down below. for my Twitch viewers, if you want to check out my video game channel, my Uncle Talks channel, they'll be in the description down below on YouTube. But for Twitch, I will post it in the chat. I will also post our Discord server in the chat as well, so you can actually join our Discord server if you want to continue to nerd out on math, or provide maybe like your own mathematical puzzles if you would like to. And I think that will do it for today, guys. So I will definitely see you tomorrow. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys in the next stream. So take care, guys. Bye-bye.